Welcome back to the Python programming series and to this explainer on Python's core data structures. In our last module, we explored lists and tuples. How to store multiple values in a single variable. Well, today, we are going one level deeper into data storage with two incredibly powerful structures, dictionaries and sets. These are the tools widely used in real, everyday applications like databases, APIs, and AI systems. But hey, before we get to the actual syntax, I want to share a really fun fact from a GitHub archival interview about the language's creator, Guido van Rossum. Did you know Python wasn't actually named after the snake? The creator was just a massive fan of Monty Python's Flying Circus. He thought that the existing patterns for naming programming languages, using boring acronyms or famous people, were just kind of dull. So as a tiny act of rebellion, he chose a six-letter word from pop culture that was easy to type, easy to remember, and carried fun connotations of comedy.
Okay, let's unpack today's roadmap. We'll start with the Zen of Python, move into defining dictionaries, explore unordered sets, learn how to construct them with displays, and finally look at data access.
Section 1. The Zen of Python, Guiding Principles of the Language.
To really get this, we first need to anchor our technical understanding in the overarching philosophy of the language. This was famously codified back in 1999 by software engineer Tim Peters. Have you ever actually typed import this into your Python interpreter? If not, you should, because you'll see this amazing Easter egg. Writing code that aligns with these 19 guiding principles is what developers call being Pythonic. It basically means you're closely following the most common idioms of the Python language, rather than just writing code that reads like a rough, clunky transcription from C or Java. Writing Pythonic code ensures efficiency, readability, and elegance. In fact, research even shows that using these Pythonic idioms can actually save memory and noticeably reduce runtime.
Moving on to Section 2, Mappings, Defining the Dictionary and the Power of Key-Value Pairs.
Let's see how this beautiful philosophy applies directly to what the official documentation calls mappings. While lists store values in a strict numerical order, sometimes we really need to store information in logical pairs. For example, imagine you need to store a student's profile. Name maps to John, age maps to 25, city maps to Toronto, right? A simple list just cannot represent this relationship clearly. And this is exactly where a dictionary, which is the primary built-in mapping type, comes to the rescue. Think of it literally like a physical dictionary, where a word is your key and the definition is your value. The official Python documentation explicitly defines these as finite sets of objects indexed by nearly arbitrary values. Now, the absolutely crucial rule here that your keys must be hashable and immutable, like a string or an integer, so the system can maintain a constant, highly efficient lookup. Oh, and here's a fantastic feature. Modern Python dictionaries strictly preserve insertion order. That means your keys will always be produced in the exact order they were originally added.
Section 3. Sets, Unordered and Unique, Eliminating Duplicates Automatically.
What's really interesting here is how Python handles collections, where we honestly don't care about the order at all, but we deeply, deeply care about uniqueness. A set is a collection of completely unique values. It automatically removes duplicates for you. Seriously, if you pass it a sequence containing the numbers 1, 2, 3, 4, 4, 5, the set instantly filters it down. Notice what happens to that duplicate 4. It just vanishes, and you're left with 1, 2, 3, 4, 5. Because sets automatically enforce the reflexivity of their unique elements, they are the absolute most Pythonic way to remove duplicates from a sequence. But you have to remember their core properties from the reference manual. They are unordered, and they are completely unindexed.
All right, Section 4, Constructing with Displays, Curly Braces in Action. The crucial point now is understanding how we actually build these structures in our code using what the language reference officially terms displays. Python provides the special syntax to construct these containers. And as you can see, both dictionaries and sets utilize curly braces, the shift bracket key on your keyboard. But their internal grammar dictates their true identity. Here is exactly how that grammar breaks down. For a dictionary, inside those curly braces, you use a colon to separate your key and your value. So you would write the string name, a colon, and then the string John. For a set, you simply provide a comma-separated list of expressions, like 1, 2, 3. Now, be incredibly careful here, guys, because both use curly braces. Providing a completely empty pair of braces creates an empty dictionary, not an empty set. To make an empty set, you must explicitly call the set constructor. Explicit is better than implicit, remember? So, we have cleanly structured our data using these Pythonic displays. We know how to build a student dictionary and a set of numbers.
But how do we explicitly access it? We need to know the rules for actually extracting, modifying, and testing that information.
Which brings us to Section 5, Subscriptions and Data Access, Retrieving and Testing Data. Let's decode the official mechanisms of what Python calls subscriptions alongside mathematical operations.
In Python, A(k) is known as a subscription. For dictionaries, you access a value by explicitly passing its exact key into the square brackets, rather than relying on a numerical index like you would with a list. So typing print, open parentheses, student, open bracket, quote, name, will output John. It's that simple. And dictionaries are mutable, too. So if our student has a birthday, boom, we just write student age equals 21, and the dictionary updates instantly. You can add brand new items the exact same way. Just type student grade equals A. Or you can remove them entirely using the del statement. Typing del student city permanently removes that mapping. Dictionaries also give us incredibly useful built-in methods like .keys, .values, and .items, which are an absolute lifesaver when you start working with loops and databases.
Sets, on the other hand, operate entirely differently. If you try to use a subscription on a set, like asking for number 0, Python will immediately throw an error because sets are unindexed. Since you literally can't use subscriptions, you interact with sets using highly optimized membership tests and mathematical comparisons. You can add an item with .add or remove one with .remove. But the true power of sets lies in evaluating data relationships. You can combine sets using a union. If set A is 1, 2, 3 and set B is 3, 4, 5, running A.union B merges them into 1, 2, 3, 4, 5. You can also find their intersection, the common values between them. For those same two sets, A.intersection B would simply return 3. This mathematical approach to data makes evaluating relationships incredibly fast. All right, before we wrap up, I have a quick mini challenge for you to test what we've just covered. Try creating a dictionary for a student with their name, age, and grade. Then update the age and add a new field for their subject. Next, try creating a set of 5 numbers with duplicates and watch as Python effortlessly filters them down for you. Today we learned what dictionaries are, how to utilize key-value mapping, how sets enforce uniqueness, and how to access and update all of this data properly. In our next module, we will learn about functions, how to build reusable blocks of code just like real software developers. So keep building and experimenting. I'll leave you with that provocative thought to consider the next time you review your code, hoping you find ways to make it simpler, explicit, and beautiful. See you in the next explainer.